Let's get some more practice with naming branched alkanes. So let's just start by really quickly reviewing our steps. First, we find the longest parent chain, which is the longest continuous chain of carbons, and then we number that parent chain starting at the end closest to the branch. Then we locate the substituents, what carbon are they on, and we name them based on how many carbons are in the substituent or the branch. And we put all of that together to make the name of the molecule. Let's look at another example. It's a little bit trickier. This molecule has two branches or two substituents on it. In that case, when we have multiple substituents, we're still going to follow the same set of rules. So step one, find the longest parent chain, the longest continuous chain of carbons. To find the longest parent chain, we're going to start at any end. It could be here, or it could be here, any carbon end. We want to start at any end and connect to any other end, and our goal is to find which path has the most carbon atoms on it. So this one that I just drew, that's a 3-carbon path, 3-carbon chain. Let's try if we go straight from left to right. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That's a 5-carbon chain. That looks pretty good. Let's check the other possibility here too. If we start up here, 1, 2, 3, 4, 5. So we've got 2 branches that have 5 carbons. In that case, when there's a tie, it really isn't going to matter which one you choose. I'll just choose this one because it's left to right. So step 1, find the parent chain. We did that. Now step 2, number the parent chain. Number the carbon atoms, starting at the end closest to our branch. Well, now we have 2 branches. We have a branch right here, and we also have a branch right here. So we have 2 branches on this particular molecule. And so our goal is always to number the parent chain at the end closest to the branch or branches. Our 2 branches are closer to the left side of the molecule than to the right side of the molecule. So that means we want to start numbering on the left side, and we want to number from left to right. 1, 2, 3, 4, 5. So there is our parent chain. And so once we get the parent chain numbered, the next thing that we want to do is locate and name our substituents. Let's start with the little guy down here, this guy. So that substituent's location is on carbon number 3, and its name, let's look back up at the names. Its name is bromo. Br, bromine, as a branch is bromo. So this is 3-bromo. Let's name our other branch. This guy's location is on carbon number 2. The name of this branch, remember, it depends on how many carbons are in that branch. That's just 1 carbon all by itself in the branch. So the 1-carbon branch, if we go back to table 12.2, the 1-carbon branch is named methyl. So this is 2-methyl. So for naming the molecule now, step 4, we are going to put the location and the name of the branch in front of the name of the parent chain. Well, this time we have 2 branches. So if we have 2 branches, we're going to need to add a step 5 here. If we have 2 or more, because we could have 3 or 4, if we have 2 or more branches, they get alphabetized. Not paying attention to numbering at all. So we are going to ignore their numbers. We're just paying attention to their names. So to name this molecule that we're working on, our branches are 2-methyl and 3-bromo. And we alphabetize them. Bromo comes before methyl in the alphabet, which means that in the name of this molecule, 3-bromo comes first, the name of that branch. And then we're going to follow it by our other branch, which is named 2-methyl. Remember, we're always putting the dashes or the hyphens in between the location and the name. And then, since we've got our branches named, we're going to follow that up with the name of our parent chain. Our parent chain is a 5-carbon chain. Let's go back to table 12.1, 5-carbon straight chain alkane, name pentane. So we're going to put that at the end of the name. And the last thing that we have to do here, in between branches in the molecule's name, we put a dash. So it's 3-bromo dash 2-methyl pentane. That's tricky. Let's try another example. Let's do it again. So step 1, find the longest continuous chain of carbons. Find the parent chain. We can start at any carbon at the end of a chain. So this carbon, or this carbon. We can start at any one, and we can count to any one that we want. But our goal is to find the longest chain. So if we start at the left and we count down, 1, 2, 3, that's 4. That's one option. Let's try a different path. If we start at the left and go all the way to the right, 1, 2, 3, 4, 5, 6. That's a better option. That's probably our longest chain, but let's check the other one just in case. 1, 2, 3, 4, 5. Nope, 5 is shorter than 6. So our parent chain is 1, 2, 3, 4, 5, 6. There it is. So that's our first step. Second step is to number that parent chain. We're going to start at either end. We're going to start at whichever end is closest to our branches. The carbon on the right-hand side is closest to our fluorine substituent, so we want to start on that end. I lost my highlight. We want to start on that end and number from right to left. Again, we're starting at the end of the molecule that is closest to any one of our branches. Our next job is to locate and name our branches. So let's do this one first. This guy's location is on carbon number 4. It is a 1-carbon branch. Let's look back up at our data table. It looks like I'm frozen. I can't scroll up. Oh, there we go. A 1-carbon branch up to table 12.2. Its name is methyl. So its location is 4 and its name is methyl. Now let's go with our other branch. Location first, it's located on carbon number 2, and its name, let's scroll back up, it's a fluorine, so its name is fluoro. To name this molecule, we are going to put the branches first, and we're going to alphabetize them. So we're alphabetizing fluoro versus methyl. Fluoro comes first in the alphabet. So we say the location and the name, 2-fluoro, of our first branch. And then for the second one, we say its location and its name, 4-methyl. And then we follow that by the name of the parent chain. This is a 6-carbon parent chain, so we go back up to table 12.1. 6-carbon parent chain, the name is hexane.